what I'm doing wrong. Now, while you guys are taking this quiz, I'm going to pull the polyatomic ion list out from where it's embedded and stick it into this 6 weeks module at the top. You need to know your polyatomic ions. These, because they're all over the place. And I did a lot of grading for you guys. I don't think I put it in Parent Portal, but I have up through skeleton equations graded if they were turned in on paper, if they were turned in Canvas. That was where I stopped. So I did grade the review that we did over making compounds and then the types of reactions. Yeah, I only graded the ones that were in paper. Do what now? Okay. For the opener, there are 7 diatomic elements. What are they? 7 of them. Oxygen, iodine, or iodine. I've heard it pronounced both ways. Chlorine, nitrogen, not carbon. We said oxygen, iodine, we said chlorine. What did you say? Hydrogen. We said iodine, we said chlorine, we said oxygen, nitrogen, hydrogen. There's 2 more. Bromine and
This one.
no. You're like, no. The one with the F, chlorine. Okay, so if I get my dry erase version of this out, look, y'all, I need to get some new dry erase markers because they're in that shape. Look, they literally make A7 before hydrogen's left off by itself. Now, and then I list them starting with iodine. I go up and then over. So it's iodine, bromine, chlorine, oxygen, nitrogen, and hydrogen. So what makes them different than the other 111 elements that are up there? What is different about these 7 versus platinum? Or don't tell me the name, because obviously I know that. Or calcium. Nitrogen is one of them. What's the difference between these 7 and the other 111 when they're by themselves? What is the difference between them? Sure, you gotta take prosody. We have a quiz about to do. What does diatomic mean? Atomic. 2. So what do these 7 elements get when they're by themselves if the other 111 don't? A 2. So when we write oxygen gas, it's not just O, it's O2. Iodine, which is a solid, it's not a gas, it's not just I, it's I2. But the other 111, let's say it's gold. You're talking about gold, it's just AU. Yes. Let's see, now let me pull, let me make sure that there's not a access code on the quiz. I don't think there is. I don't think there is. I didn't put one on it. There's one on there. It was Miss Cowan that did it. All right, so I'm going to give you guys the next couple minutes while I'm checking. Oh, wait, did I forget? No. I take your openers. I look and see how many you've done. I mark them. I mark them if you've done them or not. And then at progress report, I look to see how many you've done in relationship to how many you should have done. If you've done enough, you get 100 over. If you don't, then I figure out how much each of the ones that you did do are worth, and you get that rate. And then I do it again at the end of the 6 weeks. It's locked? It's, I probably put the wrong date on it. Today, oh, because today's the 11th. I'm sorry. I apologize. Refresh it now and it'll work. I put tomorrow's open date, which is the due date, technically. But, so if it was locked, refresh it. I just had to change it to today from tomorrow. My bad. And then when you're done with that, is there anybody that wants a paper version of the notes that we are doing? They are in Canvas. The notes are test grade at the end of every 6 weeks. Yes. They've been a test grade at the end of every 6 weeks. Notes? Yes. Who else wants a paper version? I'm pretty sure. Wait. Who else wants a paper version? The opener or not the opener, the quiz. Some of you are probably already finished. You're just identifying the class size. Did I miss anybody that wanted paper? Okay. We put this over here. If you had not turned in the assignment on skeleton equations, and some of you may need me to go over this again, so I understand what you're doing. That's technically due today, whether it be submitted digitally or in paper. Some of you did turn that in already on paper. I got one from Tiffany, Mia, and Jimmy. The paper version of the assignment from Thursday, which is technically due today over skeleton equations.
Oh, I didn't do that.
All right, let's see. Let me look and see how you guys are doing. I haven't moved anything over into Parent Portal yet. And really the only things that I've put in were the one from Tuesday, which was the review, the one from Wednesday, which was the identifying the types of reactions. And then if you turn in the paper version of skeletons, I had put that into Canvas, but I have not moved anything over to Parent Portal. Does it say skeleton equations number 1 on it? Yep. So what we're doing, Jared, you're opening up that quiz. There's a quiz in Canvas. I had to change the date to today. It says quiz chemical reaction types. The quiz that you guys should be doing in Canvas right now.
I forgot what the difference between combustion and
Think of fire. What does fire, what's needed for fire for combustion, and that should help you. What is necessary for fire with combustion, and that should help you.
I don't even know if I did that.
Okay, it looks like Declan's done, and it looks like Jimmy's done, and Sahara's done.
I got one left.
Good. It's just one of each. Okay, let me do attendance. Okay, if you are finished with the quiz, we'll start up the notes here in a second. It is a quiz. You're adding things for addition. Modules, we're on the 11th. Okay. Yep. It is much easier to navigate my Canvas using module. Braden's here, Caitlin's here. Uh-oh, somebody just made a comment. There is no code. Okay, I see Alexis. No, we're not going to throw him out the window. Okay, and then Sahara's here, Tiffany's here, Lucas is here, Declan's online, Tatiana's here, Alexis is online. Sebastian is not behind you, is he? No. Sebastian did what? Hold his back up, y'all. Keep these things up. I don't want to catch your cooties. Wait, evacuated. Like gas or pull this up like 50th time. Oh, they're sanitizing it. Aiden, no. Logan, Jeremiah. Aiden. All right, do y'all need another minute or two to be able to finish this quiz? All right. Let me refresh it and I will look. I'm still at a lot of people that have not finished their quiz yet. You're just identifying the type. You're not. There's one of each. There are no tricks. No. That doesn't matter. None of that. You're just identifying which type is it. Keep hearing bloops on the Google. All right, who are we waiting on? We're waiting on. No, you get one attempt. It's a quiz. We're waiting on Bailey. We're waiting on Luke, Lucas. Sebastian's not in here. Matthew's not in here. Logan, Tatiana. Aiden's not in here. Robert, Reagan, Slate's online. Braden, Jeremiah's not in here. I am waiting on you. I'm going to move that polyatomic ion chart up so that you guys can see it. Let's see, that was back in November, I think. Polyatomic ion chart. No, it's not there. Careful now. Here we go.
That's the second one today.
Copy to. All right, I am moving that polyatomic ion chart to the top right now. Okay, we should be done with this quiz. All right, because I have to go forward. Okay, we will run out of time if I do not, and I know some of you are confused.
Yeah, I tried. Where'd you get it?
Yeah. So, these 7, y'all hush. These are diatomic elements. This is their elemental form. They literally make a 7 on the periodic table. And if you start with iodine, you go straight up till you hit fluorine, you go over to nitrogen, and then you have to jump over to hydrogen. Literally makes a number 7. Only when they're by themselves are they like this. Because if they're in a compound, you're either going to have a prefix that tells you how many, if it's molecular or covalent, or you have to look up the charge and crisscross them if they don't have a 0. And all the other elements, like calcium by itself, is just Ca. Iron by itself is just Fe. Now, you need to know if it's iron 2 or iron 3, but that has nothing to do with iron by itself. That has to do with iron in a compound. Carbon is just C. But if it says tetracarbon, then there would be 4 carbons. So when I was going through, for those of you that turned in your skeleton equation one that I already graded, I noticed some people, when I said chlorine, like sodium reacts with chlorine to make sodium chloride, if you just said Cl by itself, then it was wrong, because Sodium is by itself, Na is by itself, but the chlorine, when you do a plus, the chlorine should have had a 2. If it didn't have a 2, it was wrong. Oxygen gas by itself is O2. In fact, most of these are gases. Chlorine, fluorine, oxygen, nitrogen, and hydrogen, those are all gases in their normal state. Bromine is a liquid in its normal state, and iodine is a solid in its normal state, but that doesn't affect how many of the number. If you do not pay attention to these 7, your skeleton will be wrong. If your skeleton is wrong, what I'm going to show you guys how to do Wednesday, I just found out I'm not going to be here Thursday. All the chemistry people are being forced to do a region 4 thing. I don't know. So I'm going to have to record this and upload it because I'm going to be going all day long. Looking at the subscripts between the left and the right of the arrow, you have to figure out how to fix it so that they're equal on both sides. That's called balancing. And we're going to be spending time balancing Wednesday, Thursday, which I will pre-record the lesson and I will upload what I was going to do anyways. Thursday is actually the harder balancing. So guess what we get to do Friday? We're making sure you don't have problems balancing. Because if I am not mistaken, no, I don't think your test is Tuesday. It's the following Tuesday. So not, let's see. Martin Luther King Day is the 18th, right? So not the 19th, but the following Tuesday, I believe is your test. Huh? Martin Luther King, I think it's Monday the 18th. Is it Monday the 18th? Today's the 11th, right? Yeah, we're out on Monday. Yes. 3-day weekend this weekend. You know, I don't know. There's certain days that I don't know. I don't look at the calendar. I don't know. When you are reading a sentence, the reactants are the starting substances. So they go on the left. Now we read left to right, top to bottom. So the starting things, they're going to go on the left. Those are called reactants. When I say on the left, I mean the left of the arrow. If there's more than one, it gets a plus sign. If sodium reacts with chlorine gas, it's Na plus Cl2. And then we have the arrow, which is the reaction itself. So to produce, to create, if it yields, if it forms, there are other words to put here. Now, if it's a gas, like with the elephant toothpaste stuff, bubbles, that's called evolution of a gas. That is a product. But if there's more than one product, remember all products, they're the things that are ending. If there's more than one of those, they get a plus. The word and is a plus sign. If it's formed, if it's produced, if it's created, if it's a yield, that's an arrow. But like I said, if you don't get the formula's right, the skeleton's wrong. If you don't get the skeleton right, the balancing's wrong. If you don't get the balancing right, the mole ratio is wrong. And if the mole ratio is wrong, say bye-bye to stoichiometry because you're never going to figure it out. Okay, so once again, creating the formula the right way is crucial. It is the first step in this. That's why we kept going over it. That's why we've been taking so much time doing this. So once again, if you're like, Ms. Archie, where do you get the charges from? I need to fix it now. What? Within reason. Yeah. So the 7 diatomics, for those 7 that we listed, diatomic means 2 atoms. Reactants go on the left of the arrow. The products go on the right of the arrow. The reaction itself is the arrow. The actual thing, the light that is produced, the thing that is burnt, like the actual change is the arrow. And there's different words that mean the change. How do you what? That's on the next slide. This is not the one that the other chemistry teachers are using. If you notice, this looks a lot different. This was the one that I made because I knew some of you needed extra help. I know you do because you're not asking questions. And then when I grade your work, it's all kinds of a hot mess. I said, I can't. if you let me show you, you have to tell me if you don't understand first. And please don't say when I ask, what don't you understand? Do not tell me everything. Like specifically, I don't know when to use the parentheses. I don't know when to look at the polyatomic chart. I don't know where that Roman numeral goes. Or I don't know why, if it's iron 2, why isn't it Fe2? It's +2, it's not how many. So there's little things like that. And I know I need to pass a bunch of stuff back. Oh, if I mark out what's wrong, okay, wait a minute, I did that right. Oh, no, you did something wrong. I need to figure out how to fix it. I'm not kidding. This class is about to get a whole heck of a lot harder. All right, so this is very, very similar to something that if I made the test that I would ask you guys to do for a test question. Your test question would say, nickel reacts with copper 2 sulfate to produce nickel 1 sulfate and copper. And then from there, if you need to, the first step needs to be write it out in words. This was part of that lab. So nickel reacts, reactant. Nickel reacts with plus sign. Oh, that's supposed to say copper 2 sulfate, not iron 2 sulfate. Let me fix it. Let me fix it. Copper. So that is Cu. Yeah, hold on. Let me fix my typo real quick. I gotta fix my typo. I apologize. I don't do it on purpose. I'd rather. You need me to go back somewhere? What do you need me to go back to? I'm sorry, what?
Like what words usually mean reaction?
Okay, so the words that mean a reaction is taking place are these. It'll say that something is produced or it forms this. Yield is the chemistry specific phrase. Yield is a product. It's not a word that we use a lot in regular English language to mean that, but in chemistry, that's a very, very common one to use.
Oh,
What?
how do we reference a nuclear reaction?
That's the arrow. That's this. Where the starting things are going to go on the left of it, the reaction itself is the arrow. It could be temperature. Different things happen in a chemical reaction. And then the things that are created, the end products, they go on the right-hand side. Was there another question? All right, so now that I fixed my typo. So nickel reacts with copper 2 sulfate to produce nickel 1 sulfate and copper. Now, I don't know if it was this class. I know in my 8th period. What does the ending 8 mean? It's a polyatomic ion. Okay, so now I just moved that chart up to the top of this module. If you see the ending 8 or 8, it is one of these. Now this one has sulfur in it. Okay, so it's one of, I can't read through the paper. It's one of these two. So when you look that up, there's sulfite, which is SO3 with a -2, but this one's sulfate, which is SO4 with a -2. So nickel, let's start with this. Is this one of the 7 special elements? No. So it's just Ni. What does the Roman numeral 2 tell you about the copper? It's a +2. This is something I'm seeing. It doesn't mean that there's 2 of them. It means that metal has a +2 charge. Copper 1, the other copper has a +1 charge. This is copper 2. Then you'd have to look up sulfate. And on that polyatomic ion chart, sulfate is 1 sulfur that is attached to 4 oxygens. And the whole thing carries a -2 charge. I know we have to build it, but we're going to do all these first. What does the Roman numeral 1 tell you about nickel? Nickel is Ni. That's +1. All Roman numerals are positive charges. I don't have to look sulfate back up. I already did it. And then is copper one of the 7 elements? No, so it's just Cu. So I have to, this is okay. I don't have to do anything to that. What's the formula for the copper 2 sulfate? Okay, look at the charges. Plus, well, hold on, but plus 2 minus 2, does that add up to 0? So I don't have to crisscross and I just rewrite what I see. Y'all, you cannot leave this 4 off. That's part of sulfate. Now these don't add up to 0. So when you crisscross them, how many nickels do you need?
2.
You need 2. This charge tells you how many of the other one is necessary. Now I don't need parentheses because I only have 1 sulfate. You only need parentheses for these guys if there's more than 1. And then do I have to do anything special to copper?
No.
Yeah. This is the skeleton equation for this formula. Now it's not balanced, but we're not doing that part yet. Now what type of reaction is this? You just had a quiz over it. What is it? What type? It's a single replacement reaction. Jimmy shouldn't be allowed to answer anything.
Yes, she is that.
Make sure I didn't do a typo on the other one, and I don't think I did. Okay. I swear, I don't make mistakes on purpose, but I am human, and I am the first person to own up. Like, oh, well, oops, let me fix it. Goodness. Does it say on your paper that way too?
Well,
Yes. I'll fix it. Wait, let me fix it. No, I know. Because when I was putting this together, sodium. Yours does say sodium on your paper, right? Okay. You can see what I'm doing online. You guys can't see. Sodium sulfate. It's an easy fix. And you guys should know the formula for water by now. H2O. Do you know what the scientific term for water is? Because it's not water. How do you say 2? So dihydrogen what? There we go. I fixed it. Okay, I fixed it. I must have been tired. Something happened. My cat must have been trying to stomp on my keyboard or my kid was acting crazy. All right, so sodium hydroxide reacts with, okay, with is a plus sign. Now, you don't know the formula for sulfuric acid, so I rewrote it. I rewrote it a way that you would be able to understand it. It is hydrogen sulfate. If it's in the acid form, if it's aqueous, it's sulfuric acid. If it's in the solid form, it's hydrogen sulfate. You guys haven't learned your acid rules, but you can do it this way. So I rewrote it in a language that you should be able to understand. So when it's going to produce arrow, sodium sulfate, and water. What's the symbol for sodium?
Yeah.
Na, and it is plus how much? How positive is it? Positive 1. Let me get all my arrows and stuff on. No, so just to, so anybody that does not understand why this is plus 1 at this point. Everything in group 1 is plus 1. Sodium is in group 1. These are all plus 1. These are all plus 2. These are all have multiple charges. This is the only one that's always plus 3. The other ones, those all need Roman numerals except for aluminum, zinc, cadmium, and silver. Hydroxide. Hydroxide is not up there. Hydroxide is on here. What is the formula for hydroxide? It is one of the only ones on here that is not an 8 or an 8. What is the formula for hydroxide? Ooh, no. This is one that we use all the time in this class. Okay, well, hold on. Hydrogen is H. It normally gets what charge up there? No. Positive one. It's in group one. Sulfate is on here. Sulfate is SO4 with a -2. Now, I don't really have to look anything up anymore. So sodium is +1. Sulfate is -2. How do you do water again? H2O. If you take organic or biochemistry, if you end up going into a science-heavy four-year college, when you write water, you do not write it that way. You write it as HOH. It is a hydrogen and a hydroxide that are chemically combined, but we normally just write it H2O. Because in biochemistry, it's a 1-to-1 ratio, but when water splits and does its thing, this is how it splits. And this is the acid, and this is the base. Which is why water's neutral, is it's perfectly half and half, it's even. If you go that route, and you end up taking organic and biochemistry, treat it like a foreign language, you cannot memorize. You cannot memorize it at all. You have to learn the language of those things. Okay, build sodium hydroxide. Does it already add to 0? It is NaOH. Now the sulfuric acid, which I turned around and named it hydrogen sulfate, what would this be? H2SO4. Once again, you only need parentheses on a polyatomic if there's more than one. What about the sodium sulfate? Na2, come on, animate, Na2SO4. And then it's just water. Is this balanced? No. 2, 3, 2. Yeah, it's not balanced. But I haven't taught you guys how to do that yet. I'm going to show you the long way, and then I'm going to show you what I was just doing in my head. You know, that is essentially the little review that I was doing for this. We're going to sort of go, we're not even really going backwards. I need to make sure tomorrow that you understand what these subscripts are meaning, and if I put a number in the front of the whole compound, what that means. So we're literally counting atoms tomorrow. Literally counting them. There is an assignment that goes with this. It is exactly what we just did. Very similar to the one that you guys did on Thursday. Who did not pick this up and look at the Friday?
Do you have to like balance it?
No, you do not need to balance it. You are doing exactly you are. Got it. It's number 2. Got it. Exactly what we just did. Who else wants the actual paper version of this? It is in Canvas. If you did not turn in the number 1, that has been due. The lab paper, which I have not graded that. Were there questions about the skeletons on the lab paper? No, this is the second set. Yeah, it's the same thing.
So the first one is it?
Yeah. You gonna do yours online? Once again, I put the polyatomics on the very top of today's module. If you lost it, I don't know, you never got it. Are there any specific questions? I don't know where this is coming from. What is what? Silver is Ag. But what's its charge? It's always +1. That's why it doesn't get a Roman numeral. Zinc is always +2. Cadmium is always +2. Silver is always +1. And aluminum is always +3. That is why they don't get a Roman numeral. They don't need it.